So we're here to talk about declaring bankruptcy on technical debt. A little bit of symbolism here. This is us surrounded by problems, thinking everything is okay. We decided enough was enough, and it's time to take action. My name is Brian Cassidy. I'm Senior Web Developer here at the University of New Brunswick Libraries.
I'm Jacob Sanford, Infrastructure Solutions Architect here at UNB Libraries. And we wanted to present because we feel like this is something we should all talk about. Some of the problems we'll be presenting during this session will be common for a lot of academic institutions or public institutions, especially libraries with homegrown IT services, as most of us have risen from. And in these cases, organic development, organic IT infrastructure development tends to run amok and create some issues. So it's important to mention that everything we're discussing here today was done as a group effort. We wanted this session to be more sharing of experiences, the problems we faced, how we coped. There's very few novel ideas here. We are not holding ourselves up on an ivory tower looking down at you all. This is just more of a discussion in how we dealt with things. And the standards we chose to adopt to clean up our problems. So in the beginning, things seemed limitless. In 1989, the TCP/IP router stack was rolled out at UNB, making it a cross-campus TCP/IP. 1991, Phoenix, our library catalog, which is homegrown, was placed online through access through Telnet, which was really innovative. And in 1993, at the library, we launched the first comprehensive university website in Canada, umb.ca. We were very proud of ourselves. This was breaking new ground. So we began to pose for photographs with computers. In 1995, we retired Phoenix, the homegrown catalog, purchased the Cersei product Quest. This came with WebCat, which gave a web-based catalog, so patrons no longer needed Telnet to access the catalog. This provided a more human interface. And things were going so well now, it was important to step things up. The complexity of our promotional photographs needed to increase. So we pictured in the photograph, John Teskey, present today, Andy Pope, and Alan Burke. So at this point, like others, our web presence and IT services underwent what I would call rapid expansion. We developed a comprehensive library website. We began disseminating e-journals, and flash forward many, many years. We then held dozens of web properties, and they contained an enormous amount of public-facing knowledge. And this was really being noticed. We were getting out there. And again, I would note the space book in the logo. So we were doing great things. We were proud of them. But much like those who scale Everest, things do get left behind. And we were leaving a lot of problems behind us. And what we were leaving behind us began to disrupt our day. And eventually, it came to consume our day. The staff at the time wasn't growing with the assets we were producing, new projects we were developing. Our dependencies, our architecture were a mess. We felt like firemen instead of system staff, where we were putting out an endless series of fires, and the only decision was, the only way to prioritize was, what fire do we want to put out first? And even worse, it was becoming increasingly clear because of this organic growth, because of the transient staff, because of our lack of documentation, we didn't even really know what we had.
So where do we start? How do we untangle this mess? We thought it would be best to start with identifying our obstacles, and we decided to break them down into two areas, one being policy related and the other technical. So first with policy, we had a growing number of projects, and as Jake mentioned, our staff really was the same people. With respect to our products and services, we were very reactive to any issues rather than having preventative measures in place. We rarely said no to anything, and we didn't really have any metrics to just help us decide when we should say no. On the technical side, we had local copies and backups of projects, but no copy of record or central repository for source code management. We had varying server OSs, web frameworks, both custom and open sourced, mixed versions thereof, and differing deployments on development and production servers. Very little documentation, and what was there was probably outdated. This pretty much speaks for itself, no tests whatsoever. And we had few standard practices for future project development. So,
all right, so we had to stop the bleeding. We had to decide that what we had was, for the most part, no longer serviceable. We had to assess debt, cut out a lot, and essentially declare bankruptcy.
I have to go to the next
over here. Aha. So around that time, Jeff Atwood posted on his blog some general thoughts about dealing with this problem. We liked it, and it's how we moved forward. We began embracing, and I'll paraphrase here, the awfulness of what we had. So the first step was to figure out what we had, as I mentioned, and document it. So we started a wiki. And we began listing the projects, assets, owners, frameworks, everything about what we were tasked with supporting. Now, I'm clicking slides very fast, and I apologize for the brevity, the speed of this. We're going to cover a lot of ground. Details on most of what we discuss on these slides is available on our talk page on shed.org, sketch.org. Also, please talk to us. We'd love to talk about any of this. So after determining what we had, the first step was to look at the hardware. So previously we had racks of bare metal, lots of colos, lots of hardware to manage. Rack space was at a premium, cooling. Virtualization helped solve these problems. The product we chose was VMware vSphere. And as a first step, we directly migrated our hardware one-to-one into virtual machines that were split across a couple of hosts. Now at this point, you may be saying, wait, why not Amazon? And this may be common to a lot of you. Two reasons: we already had a lot of hardware, and so we wanted to use it, what we had. And also there was a general feeling that the assets of the library should stay inside the library. So that was out of our hands. But Amazon, Rackspace, whatever, they're wonderful solutions, and I would encourage any of you to explore them if that's what you're looking at. So after addressing our hardware problems, we also realized our operating systems were a mess. We had Cent, Fedora, SUSE, BSD. This caused a really large maintenance burden, doing operating system updates, dealing with this. Some operating systems had a really short upgrade cycle, 18 months, which meant we were just always doing SUSE enterprise updates. So we standardized on an operating system, Ubuntu. It had an LTS product, which was 5 years of support with an install. Additionally, where previously we had installed operating systems with memory keys or CDs, we began using a bare metal provisioner called Razor Server. This allowed us to codify operating system installs from metadata and then pass that on to configuration management. So once the operating systems were on the instances, with respect to configuration management, previously this was also a nightmare. There's manual package installations. The paths were wildly varying between servers. UIDs weren't standardized. So we chose Chef for this. and set up a chef server. After the configuration management problem was solved, we then moved on to our projects themselves, and they existed in countless frameworks, tons of languages, and a lot of custom work. So the skills at the time in our shop were PHP mainly, so we chose to standardize our projects into PHP where possible, with other needs being met by Python and Django for web access. Some of our support tools had other needs, so I also mentioned Node here and Cucumber. But one of the most important things was we said, okay, instead of asking what language does this fit into, we said, why not PHP and Drupal? This goes against what's disseminated in the pragmatic programmer, but this is what we needed to do. And version control did exist, but not in a meaningful way. And this is one you may be familiar with. Index.Wednesday, very descriptive. So we had to leverage version control systems. And we knew we wanted a distributed version control system. Many existed. Git was the one that was very popular in open source communities, and it's the one we had the most experience with. So we went with Git. But Git also came with GitHub, which gave us a canonical central location in a distributed version control system environment. So this kind of gave us a way to do this in public, referencing Atwood's blog post earlier. So October 2013, we did our first commit, and all our problems were solved. But really, after our first commit, how do we proceed? Well, we had an enormous amount of assets that we needed to then migrate into our new system. So we went back to the blog, started standardizing, documenting how we were going to proceed, define structure, define stages, goals, and steps to have this all written down. And then in excruciating detail, we had to map out all parts of our web assets. And this was a very fun job. And it made us realize that the path ahead was even more enormous than we thought. How could we break all of this up in a reasonable manner, move it into chunks that our team could attack together instead of just one person? What was a reasonable way to do so? So we decided that we needed
project management or a ticketing system. So for that, we chose a product called Fogbugs. It sort of aligned with what we needed at the time. It features an email inbox polling, some custom fields, custom workflows, and really, most importantly, a read-write API. So here we're taking all of our projects and matching projects in Fogbugs. We have tasks in each with priorities and assigned to system staff. We integrated, using the API, a trouble ticket portion of our website. So staff and patrons can submit their issues directly to there, and it goes into our Fogbug system. We even extended the integration to our reserve system for copyright clearance, a bit of a novel way to do it, but it uses the custom fields and workflows quite elegantly. So projects are now being tracked in Fogbugs and Git, not only just code for projects, but server configurations. But it's still manually deployed by copying files to servers. We wanted to get away from that, so we wanted to automate this process using Jenkins, which is a continuous integration server, and Task Runner, which is what our primary usage was. So a little bit how we did it. On GitHub, you can add a Jenkins webhook and specify your Jenkins server URL. In Jenkins, you can tell the task which GitHub repository to look at and track, as well as the branch, so you can customize that. Next, we add a build step, which pushes the Git repo to our deployment server via SSH. This requires a bit of setup on the server. At the time, the option for that was a bare repository. Newer versions of Git, apparently you can do a direct deployment, but this is what we required at the time. In the bare repository, you have to add a post-receive hook, a bash script in this case, which checks out the repository to our destination folder. As a bonus here in this little script, we're doing some looking at the git commits for modifications to our composer.json file, which will automatically run a composer update on our dependencies. So you can extend that kind of process for things like restarting Apache on server config changes as well in an automated fashion. So our web tree is now on GitHub, and changes are automatically deployed to our production server as commits come in. But the website is maintained by more than just the system staff who know Git. We need to support those users still. That brings in and set up for on a development server an LDAP-controlled SFTP account for each user. Common group for these users so they have access to the web tree. We mount editable paths to their home directories, and the difference there between that and a symlink is if you use a symlink and you go back a directory, you're now in the middle of the web root, whereas a mounted path means you're back at your home directory and it kind of sections them off. Here's a bunch of technical details about that, and I'm not going to go into that too much, but for your reference, when you view our slides later, it's all here. Yeah. WebTree is now a Git repository, as I said, but we need to abstract that whole Git process to these other users. So we created a little Django app called Web Update. Brilliant name. It's an LDAP authenticated again, web front end to Git. So here's a little example of a list of changes that a user might see. It's basically the same thing as a Git diff, so a little bit of knowledge there they have to catch up with, but pretty easy to look at. Then we've abstracted out the Git commit interface. You can pick one file, many files, and then add a message, which turns into a Git commit message. Once they press submit on that, it automatically generates a pull request on GitHub, and system staff are notified and can process that as necessary. So now there's no more manual deployment to production servers, but we still need to know when things are up and running. That brings us to monitoring. We're currently using a combination of Nagios and New Relic. Here's a Nagios example with server level info such as disk space, load, some daemon status like Apache and MySQL, and system staff will receive notification when there's any warnings or failures thereof. And in New Relic, we have both server and, more interestingly, application level monitoring, which we hope to explore a little bit more in the future, but this is why we're still using a bit of both. We're not fully invested in either. So now, deployment's automated. We know things are still running, but is the app working as we expect? Let's add some tests. For that part, we chose Node.js with Cucumber.js and Phantom.js. This combination provides a functional headless browser with a testing interface. And that looks something like this. This is a Cucumber-themed name Gherkin syntax, which is an English-like user story. It's divided into features with one or more scenarios. Example here, one of the scenarios is viewing the main page. We can see the title tag is there and the contents match what we expect. You still have to write some Node.js code underneath, but it's a write once, reuse everywhere across the test suite thing. So we can write the title tag should be visible, or sorry, the X tag should be visible, and that's used all over our test suite. So now we have a test suite, but we need to report on those results. So we need to run it on a regular basis. And to do that, we bring Jenkins back into the picture. We set up Jenkins to run the test suite every 3 minutes for ours, since that's the basic length of our test suite plus a little buffer room. There's a Cucumber plugin for Jenkins, which will break down our test results by feature and also shows any failing scenarios here. WorldCat in this case. Sorry. You can get details on that scenario line by line, and we can also embed a screenshot thanks to Phantom.js's screenshot capability. I won't show what that looks like though. We also added a post hook in Jenkins to update our server status on our website so patrons and staff can see real-time service information. Now, all those tests are being run inside our own network, so we're kind of in an enclosed space. What about people who are off the campus network? We set up an AWS Micro EC2 instance and decided to run tiny proxy to mimic outside traffic. And that seemed to satisfy that in what we needed. So let's rewind a little bit for Jake and talk about frameworks.
So one of the frameworks I mentioned was Drupal. We had several Drupal sites already. Wasn't ideal because there were several versions. Most of the sites were using multi-site Drupal. This is a shared code base for multiple properties or applications. Multi-site does help ease the maintenance burden if you're trying to support multiple sites. But as we grew across multiple servers, some were multi-site, some were not. It's confusing to maintain. And at the time, we were beginning to shift our thinking towards applications as standalone items rather than just a collection of on-disk files. So we decided to treat each of these sites, each of our Drupal sites, as a standalone application and have a repository dedicated to each. So this is where Git comes in. We began to track the entire site tree in Git. We did this, it worked, but it worked with our deployment system, but it seemed bloated. It wasn't great. And at the time, one of our team members was Kasim Mashiudi, and he said, wait, if 95% of a Drupal tree is just Contrib code, then instead of tracking the entire site, we should develop a way to build the site from metadata using tools and then add in our custom code. So Drush makefiles were exactly what we were looking for. That year, one of our developers, Jen Whitney, attended DrupalCon Chicago. She's present today. She saw a presentation on Drush makefiles and automated builds. And that led to the development of our first Drupal build tool. So we stored makefiles for all our sites in a single repository with one site per branch. We ran a bash script on the server which read the makefiles, built the instance, but it required the script and build to be on the production server. It was a good start. And this did work for some time, but a couple years later at DrupalCon Portland, we spoke to Lullabot, and they mentioned they had solved the problem we were facing here with something they called Tugboat, which was a bash script that integrated into Jenkins and automatically built Drupal from a centralized build location and pushed it out to servers. And then the next year at DrupalCon Austin, they actually presented about it. But in the meantime, we developed a derivative of Tugboat that used our makefile and repository format. We called this Pushback. Pushback is a terrible name. What does it even mean? Well, as an aside, a pushback is the tractor here that moves airplanes from the terminal or jetway out to the runway. We thought we were very clever. It was a terrible name. It had a silly name, but it worked for us. And additionally, we moved back into tracking each site as its own repository instead of the per branch model, which just was falling apart in many ways. So we made commits to the metadata in the repository, which triggered a Jenkins build on a build server, r-synced the files to a production server or staging server, and then tested it, and then did security tests. And this helped us out a lot during Drupalgeddon in 2014 when the world fell apart for Drupal folk. This is currently available on GitHub, and it may be for you. It might be a good starting point if you're looking for a way to build your Drupal instances. It hasn't been developed in a while. We're no longer developing it. We've moved on. I'll discuss that later, but we'd be glad to talk about it. So now we have standardized production deployments. We wanted to tackle local development, which is another huge challenge we faced. And to do this, we leveraged Vagrant and VirtualBox, which you're probably familiar with, as well as our old friend Chef, acting as a configuration management server. So we wrote a Chef cookbook and recipe that matched exactly how we built Drupal with Pushback. remember that tool with the terrible name. And it leveraged this idea of makefiles and repositories, and the repository containing only metadata rather than storing files just as flat files. We then baked the Vagrant setup into a common repository for developers, so with a single command, developers can have a local environment up that exactly matches production. So this allows them to develop on identical environments with identical data and have less mussing about, and ultimately leading to less problems post-deployment. I'll tell you a secret here, I just copied and pasted that image. It's not actually local and live. So these problems were being solved, but we were vastly increasing the complexity of what we were supporting. We were a small team. Managing and monitoring these tools was becoming a job in itself, and we really needed to centralize a way to deal with our new system.
That's where chat ops comes in. So we have many things happening. We have incoming tickets and fog bugs. We have Git commits happening for various repositories. Jenkins is building things left and right. We have test results that might happen. So much going on. Where do we find out all the details on this stuff? Slack. You may be familiar with that now at this conference for the first time, or you may be using it already. We originally had an IRC daemon, but Slack is far more user-friendly, has desktop and mobile apps and a web interface, so that was a huge benefit for our team. And it has a ton of existing integrations. So here we can see Nagios is integrated, GitHub commits are showing, and our Jenkins build processes are happening right there, for example. So we want to add our own custom notifications for all these other things that don't directly integrate. How do we do that? We decided we would set up a simple notification service topic for each of the integrations we were interested in. So you can have many different kinds of subscriptions to these topics. You could have an email that's sent out, so all our system staff get emails when we have tests that are failing. You can do SMS messaging. But for integration with Slack, you should set up an HTTP subscription, which points to a little PHP script that we've written, and it receives a JSON message and then sends it to Slack via their API. And that results in these kinds of examples. So we have our test suite that will show sort of new failures, ongoing or recovered. We have our reserved section import that gives us a daily notification. We have our WMS patron load status that happens every day as well. We'll get ticket updates when those come in. We also have another little side project that will pull all of our servers for updates and notify us in the channel. So things like Ubuntu apt updates, Drupal module status updates, composer dependencies, Node.js dependencies, et cetera, and we can plug in whatever we need to that.
So I'll say it again. Everything is fixed and we have no more problems at this point. Except if you recall, with our hardware improvements, we replaced our hardware one-to-one with virtual machines. So what that meant was problems relating to server usage density still existed. It was very light. We had many servers using barely no resources. Our scalability was very poor. And this was because we still suffered from a bit of a classic infrastructure mindset. So if we were to reach the highest levels of enlightenment and ascend to becoming pure humans, we had to stop perceiving our projects as tenants of hardware and rather start perceiving them as applications that transcend hardware. Now, I know you may feel like I'm going into some new age topics here. What's coming next is far more mundane, and I hate to let you down. We'll be talking about containers. Containers are expressions of an application which contain the entire runtime environment of that application. So the application itself, the dependencies, the libraries, the binaries, the configuration, it's all in one package. And instead of abstracting at a high hardware level as virtual machines do, containers abstract at the OS level. and this allows them to share binaries instead of requiring an operating system for each virtual instance. But most importantly, and this is what's very exciting, is that containers run applications exactly the same, regardless of the hardware or host they're running on. So the world is very excited about containers now, and I'm sure you've heard about them. There's two major formats we had to choose. There was a lot of kind of discussion around this, but we found the most important factor is the format that we chose would determine the theme of how our derivative apps were named. So would we choose a nautical theme for our future tools with Drupal, or Docker, sorry, or a space theme from Rocket? We chose Docker. So our primary framework is Drupal. What was available for Docker images at the time? Well, the community Drupal image was really well used, but to our chagrin, it was actually quite large. I believe I even said bloated at the time. Each instance required over 500 megabytes per site. So with caching and stuff, this is less important, but it stood out as a problem for us. Note that the official image now is actually much smaller, and they've worked on it. I would encourage you to try it out. So we had several false starts, but after a while we developed our own image. It was based on Alpine Linux, Nginx, PHP 7, and it was around 45 meg. This base image doesn't really do much on its own. It's available on GitHub if you want to look. But you can extend it, and so we do in a very public manner. Back to the blog post. Do it in public. This repository represents the current code and configuration driving a small site, loyalistresearchnet.org. It's a simple site, but a good exemplar to use, so grab it, download it for yourself. You can run our site on your laptop if you want. Minus the DIS files, but you don't need those to see most of it. So what happened to Pushback, our old friend? Pushback was retired in favor of CargoDoc, another Drupal metadata builder. It's a good deployment suite. Note the nautical theme, very exciting. It builds Drupal instances with Jenkins and deploys containers to production servers. We control deployment with metadata. We can do rolling updates, and our production servers have Core OS as the operating system, and that serves as a node host through the Docker API. We're not pushing anything around with rsync anymore. It's just all API calls telling Docker, hey, get this container and pull it down yourself.
So now we're up to present day. Where do we go from here? What will the future bring? Maybe in the distant future, the year 2000, knowledge will be ground up and directly injected into our brains, and no one will have to worry about this. Truth is, I don't know. Who knows what's on the horizon? But what we've decided in the end is that we're going to treat infrastructure development like any other project, and we're going to create tasks with priorities for infrastructure changes and improvements that we want to do. We would be remiss if we did not thank all of the people who have been part of the team and did all of this wonderful work. So here's a list of them right now. And that is it. I'm going to go back to this while we take questions. Back on.
Shall I sing as I walk?
Please.
Hi, I'd like to underline the idea that libraries should hold on to their assets. But this leads me to a question that either I missed it or you didn't say. At my university, we don't have final control over the horizontal or the vertical. It's controlled by central IT. Is that not a problem for you?
Not exactly. We have our own setup that we control, and it's on the backs of central IT. So
But they
there is
don't try to tear it away from you? I mean, we're using AWS because they say we must use AWS, for example.
I think they've worked with us fairly well. It's
That's
a
great.
continuing and ongoing discussion, and we're happy to keep what we have so far, so we have control over it at this point.
Thanks.
Other questions?
This was a question that was actually first posed by Krista on Twitter, Krista Godfrey. But how did you get to the point that you're going to file bankruptcy, that you decided, okay, we're in a, where did that decision come from? When did you decide that that's what you're going to do? And why?
I'm a bit of a moody person, and sometimes things overwhelm me unnecessarily. But I think when we realized that our days were spent solving problems rather than improving what we had, and not solving problems in sustainable ways, doing so just to get it solved, and that consumed most of our day, then we realized, we had a problem. And admitting you have a problem, I think, is the first step, as they say. So I can't give you a definitive answer, honestly. I think we had manager Steve Rosenfeld at the time that was very supportive, and he essentially said, okay, you guys are complaining a lot. What do you need to move forward and stop complaining? And I think that's where it started.
We have time for other questions?
Yeah.
Just got to say, this side of the room's doing it.
Okay. So I guess this kind of ties into the last question, but did you develop any key performance indicators that kind of measure the improvement you've had within your unit in terms of productivity and stuff now that you've implemented all these new applications and processes?
I don't know if we actually track that per se. We don't complain as much. That's an indicator, I think. Yeah, but no, we didn't actually do any metrics from there, unfortunately. Sorry. Add to that.
I mean, I think they could be found looking back at logs and mining for them. Yeah.
I'm not familiar with this kind of stuff at all. I'm just a student, so, but I work for the government and daily management, API. So.
No, I think that is actually a helpful thing to know, to have metrics. And they could be found, I think, looking at least at logs, outages.
Or
et cetera.
fog bugs, we can go through our tickets and kind of see
Number of
where all
tickets,
that went through, but we haven't actually gone to do that yet.
Mhm.
Okay, I have no voice, so apologies. I'm interested in knowing how you manage to communicate. Moving from that firefighting, always putting out whatever is happening right now, to make this a priority and sticking to it without having everybody else come and say, I've got a problem, yours has to wait. How do you deal with that?
That answer has a lot to do with our management, actually, who has been exceptional in supporting this. Again, Steve Rosenfeld was our previous manager. James McKenzie, our new manager, asked us for input, wants ideas on how to improve, and both of them made a commitment to ensuring that what we did stuck and seeing our new way of working as the new norm rather than a one-time event that solved all our problems and then just let's get back to the way it was.
How did that work with the rest of the library? Did your admin, was the message coming from them, or how did staff know that this was going to be your priority?
Well, at the time we actually had shifted from kind of knock knock, can you do this for me, using FogBugs into a more formalized request process, and I think that eased that pain a bit. And where requests then came through managers rather than to us directly, and they were able to kind of, communicate, we have limited resources, and by the way, we're undergoing a project that limits these resources further, so, sorry, it might take a while, and we would like to, we want to help, but we have to be realistic about timeframes instead of just getting this done tomorrow. So I should not be congratulated in any way for that. That more the management than us.
I think other questions can wait till lunchtime, I hope. I just want to thank you both